Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week, and we're going to be talking about something that could very well be inhibiting our hurricane season. As many of you know, it was predicted to be one of the worst on record with 25 named storms, 12 hurricanes, and 6 majors. And the folks at Colorado State have only modified the number of named storms down 2 to 23. Normal is 14, and the hurricane projection they're keeping at 12 and 6. And so they're still going for a very active season, but we're less than 3 weeks from the climatological peak of the season, and there is absolutely nothing going on in the entire Atlantic basin. So I want to talk about one of the things that may be contributing to that. And so let's start off here with a sort of a scoreboard, if you will. Now, the Colorado State forecast was for 23 named storms. In the middle column there is the date by which you would expect each numbered storm to develop. And again, the 30-year average is 14. And so when Ernesto formed on August 12th, it was 10 days ahead of schedule. But the 6th storm normally occurs by August 29th. 1 week from today is August 30th, and there is no sign of anything developing over the course of the next week. So if this holds, then in 1 week, we will be 1 day behind a normal hurricane season, let alone a spectacular one, okay? So that's sort of interesting in of itself. Now, if you take a look at hurricanes and major hurricanes, we're still way ahead of schedule. Ernesto formed August 14th. Normally, you don't get the third hurricane of the season until September 7th. And the fourth one, we have until September 16th to pull that off. And we have until September 19th to get the second major. So with regard to hurricanes and major hurricanes, we're still pretty far ahead of schedule. But on named storms, this is just your run-of-the-mill season so far. Okay, so there's a group out of the University of Wisconsin in Madison. This satellite loop I'm going to show you is courtesy of the Cooperative Institute for Meteorological Studies at the Space Science and Engineering Center at the University of Wisconsin-Madison. And this university in Wisconsin and Madison has always been one of the top schools in the entire country for studying meteorology. They have lots of research there. You can get undergraduate degrees, graduate degrees, you can do research. It's very much along the lines of Penn State, very, very reputable institution for this particular field. And so they really specialize in satellite imagery, and one of the loops that they have is what's called a split window loop, where they can take a look at 2 different wavelengths being emitted from the atmosphere and pick up on this African dust, what we call this Saharan air layer coming off of the continent of Africa. And so everywhere you see the oranges and the yellows there are big areas of dust and this Saharan air layer that have moved westward off of Africa across the Atlantic. Now, there are several impacts that this thing can have, and so I want to go back to the PowerPoint here and talk about some of those. First of all, the Saharan air layer, or SAL for short, has 50% less moisture than a normal tropical air mass. And this is a problem because when thunderstorms form, and you all know this from thunderstorms that we get around North Carolina, that you get these downdrafts of cool air, and those downdrafts become more severe when you have a dry air mass, because that means that any rain falling into that dry air mass is going to evaporate, and the drier the air is, the more evaporation there's going to be, the more cooling there's going to be, and that cold, dense air sinks, and it can kill any updrafts going on that are trying to develop thunderstorms. So that is a problem in of itself. Then, as this warm Saharan air rides up and over the relatively cool tropical air, it creates an inversion. So you might think that the air in the tropics is warm, and it is, but the Saharan air is even warmer. And so it rides up over that relatively cool tropical air, which means you have an inversion at the interface between those 2 air masses, okay? If it's cooler underneath and it's warm above, then the temperature has to at least be steady, if not increasing with height. And inversions are not the friends of thunderstorms. Thunderstorms rely on buoyancy. Air parcels need to be warmer than their environment. And if they get up into an inversion area where the temperature is increasing with height, it can become cooler than the environment that it's in. And that pretty much puts the brakes on any additional rising motion from there. So that is an inhibiting factor as well. And then also these dust particles, or as we refer to them as aerosols, cells can reflect incoming solar radiation and lower the overall water temperature in the ocean by up to 1 degree C. And that may not sound like much, but sometimes those 1 degree differences can make a big difference on whether or not a tropical cyclone develops or not, or how strong it ends up getting. So 3 different ways that this Saharan air coming off of Africa can cause a problem. And it seems like this has become more of an occurrence in recent years. And I don't think anybody really knows why. And there's still a lot of research going on surrounding this particular issue. But nonetheless, it's a leading candidate for why things have been so quiet. There's another factor which maybe we can talk about another time. It's called the Madden-Julian oscillation, which is a wave that basically moves around the entire Earth in a period of about 30 to 60 days. And it has 8 different phases, and the second phase is highly correlated with active tropical cyclone activity in the Atlantic. Well, we're in phase 2 right now, and there ain't nothing going on, okay? So if you look at it from that perspective, and you know, it almost seems like it's got to be related to the Saharan air coming off the continent of Africa. And we'll have to wait and see whether or not the push of that dry air across the Atlantic weakens at some point in time and allows some activity to get going. But right now, at least with regard to named storms, we are right on schedule for a normal hurricane season and may fall behind if something doesn't develop after a week from now. So it's going to be really interesting to see how this turns out. All right, folks, that's it for now. Bonus weather video number 3 for this week. Next one coming up on Monday. I hope you have a great weekend, and we'll talk to you again then. Take care, everybody.